we're going to look at polynomial division and partial fractions as a way of solving an integral like this. So what we're going to do is look at how you do an integral like that by, first of all, finding out or using polynomial division on it to turn it into something that we can easily integrate. So actually that turns out to be quite straightforward to integrate once you've done this division on it. We'll look at it from the point of view of how do you do long division with numbers, and remind ourselves of that process, because the process is exactly the same algebraically. Yeah, so we're going to start by looking at that integral. How do we do this integral? We use polynomial division. To reduce this top-heavy fraction. So the question is, first of all, we need to recognise that that is a fraction, which it is, isn't it? Because it's one term over another one. And the second thing we need to recognise is that it's top-heavy. What is it that makes that top-heavy? Yeah, cubed on the top and squared underneath. So if the highest power of x, so that makes that top term a cubic, is higher than the highest term in the bottom term, which is a quadratic because it's x squared, then it's top-heavy. And we can do this polynomial division to reduce it and then turn it into something that we can integrate. What x is doesn't matter in this case. We're going to do the integral, and then we could find out what the integral is for any value of x, whether it's positive, negative, 0. Yeah, so the fact that it's x is the key thing, because that means we're doing a general thing. We can work out what this is for any value of x. So it doesn't matter whether x is positive or negative. So let's have a look and see how we do this. So first of all, division. 4's into 5,204. Start off nice and easy. What do? 4's into 5 goes once. And then what we tend to do, which we don't normally do, is we say, okay, 4's into 5 goes once. So what is 4 times 1? It's 4. So therefore, what goes underneath here? A 4. And then to get the remainder, 5 take away 4 is 1. So that 1 goes there, or we could leave the 1 here and bring the 2 down. And then we say 4's into 12. Goes 3. What is 4 times 3? It's 12. So what's the remainder? If I subtract 12 from 12, 0. So I bring down the next figure, which is a 0. How many 4's in 0? 0. Don't forget to put the 0 in. So what is 4 times 0? 0. So what goes underneath here? I'm being very pedantic here to show you the method. So the remainder is, of course, 0. And then you bring down the next number, which is the 5. And you say 4's into 5 goes once. What is 4 times 1? It's 4. 4 goes underneath. So therefore, 5 take away 4 is 1. We've got a remainder. So this can be written as, if we think about this, 4's into 5,204. What we've actually done is said 5,204 over 4, which is what we've done. 4's into 5205, yeah, thank you. Goes 1,301 times, remainder 1. But 1 what? 1 quarter, yes. So it's 1,301 and a quarter. So let's just recap that, okay? What we're doing is a division. What, of course, we would do, actually, if we go back to school, what we probably did was we went 4s into 5 goes once, remainder 1, so we put the 1 here. 4s into 12 goes 3, exactly. 4s into 0 goes 0. 4s into 5 goes once, remainder 1. So it wouldn't bother with all this underneath. Sorry, Nathan? Yeah, it would. Yeah. But what I'm after here is not, I'm not after can you do this, I'm after the method. Okay? Could use a calculator, but again, when we come to what we're aiming for, which is that sort of division, you can't use a calculator for that. So what I'm doing here is trying to show you the method. What do we do? 4s into 1, 5 goes once, remainder. Say that again. 4s into 5 goes once. What is 4 ones? And then we can work out the remainder by taking it away, and so on. Okay? So that's the process. Let's try that on the next example that I've got here for you. A long division, okay? But exactly the same process. So, what are we going to say? Yes, so 37 into 43 goes once. Right, but what we say as an aside, Mason, which is going to come in more later, how do we work out the remainder? What is 37 times 1? 37. So therefore we put the 37 underneath here, right, Mason? And then we get your 6 that you're talking about. But to set it out, we would do that. And then we bring out the next digit, which is 68. And now what do we do? Right, so again that goes once. So what is 37 times 1? 37. So that's what goes under here. Work out the remainder. 31. Bring down the next digit. Now we need to know our 37 times table. So 10 37 to 370. So 9 is going to be about 330 odd, isn't it? So it probably goes 8 times yet. So what is 37 times 8? 7 8 to 56, 3 8 to 24, 296. Okay? So what do we do with this 296? Right, so we put this underneath here and work out the remainder. I probably add up, so 4 takes us to 300, so that's 19, yeah. Bring down the next digit, 2. 37 to 92, well, 10 is 370, so 5 is half of that. Yeah, 10 is 370, so half of 370 is 150, 185. So that goes underneath here. Work out the remainder is 7. Bring down the next digit, 1. 37 into 71. Once. Remainder 3. So what is 1 times 37? 37. Oh, look. I was doing this with someone else earlier. Reveal the answer is 37. Remainder 3 into 4, 35. Isn't it? 34. So it goes, we can then say that 438521 over 37 is 111 and 34 37ths. Done. Long division. So the way we set it out is really helpful when it comes to algebra. So let's look at an example where we're going to do a polynomial division, as it's called. Well, we'll come back to that one in the end, Mason, okay? So let's have a look at an example. Here's one, 5x squared plus 17x plus 6 over x plus 3. So I set it out exactly as I would a long division, x plus 3 into 5x squared plus 17x plus 6. So I'll let you just get that far. So in this polynomial division, we write it out as a division like this and then go through exactly the same process as we did before. But what we do is we focus on this what have I got to do to the x to get it to be the first term, which is 5x squared? And you'll see why as we go along. So you just focus on the x part of the term, the highest power of x in that term, and ask yourself, what have I got to do to get that to be this term in here? So what have I got to multiply x by to get 5x squared? 5x. So that's what goes on top. But then I say, as we did before, what is 5x times x plus 3? What is this 5x times x plus 3? Work it out. 5x times x, 5x squared. 5x times 3, 15x. Okay? So that is what goes underneath. 5x squared plus 15x. And then I work out the remainder like we did before. 5x squared minus 5x squared has gone. And that must happen. That's what we made happen. We asked ourselves, what happens to the x to get 5x squared times by 5x to make sure that that disappears. That's why we did it. And then 17x minus 15x is 2x. And then we bring down the next number, plus 6. What have I got to times x by, using my magic pen, to get 2x? So that's what goes at the top, plus 2, because it's a positive 2 I've got to multiply it by. What is x plus 3 as an aside, or what is 2 times x plus 3? 2x plus 6. So that's what goes underneath. And we find that, in fact, for this example, there's no remainder, it goes exactly. So in other words, this means that this whole thing, 5x squared plus 17x plus 6, over x plus 3 is in fact the answer, which is 5x plus 2. Now, before you write it down, let's just look back. If I'd done this, what would I do to check I'd done this right? I'd do 4 times 1,301, and I should get back to that, shouldn't I? So to check this, I would go, what is 5x plus 2 times x plus 3? Answer, 5x times x. I multiply everything in this one by everything in that one. So 5x times x, 5x times 3, 2 times x, 2 times 3. So 5x times x, 5x squared, plus 15x, plus 2x, plus 6 becomes 5x squared plus 17x plus 6, which is what we started off with. Okay, just make a note of that and I'll pause it. So the first thing you ask yourself is, first of all, are we going to do a polynomial division? And you do it if it's top heavy. So is it top heavy? Yeah. Okay. In the same way, if I've got the fraction 2 over 3, I wouldn't do that division because it's not top heavy. I'm not going to get whole numbers. But if it's 3 over 2, then I am. So top heavy fractions is when you do this polynomial division. So, right, that's what we're going to do. So the first step is to say what? Right, so ask yourself, what have we got to do to the x to get x cubed? Answer? Right, x squared. So as an aside, I work out what x squared times x minus 1 is. Answer? Minus x squared. Yep. And so that's what goes underneath here, x cubed minus x squared. And then we work out the remainder. Now, watch this one. X cubed minus x cubed, gone. Okay, that must happen. If that doesn't happen, you've gone wrong. So x cubed minus x cubed gives you the 0. This is the important one to be careful of because we've got a double negative. 3x squared minus x squared is plus x squared. That gives us 4x squared. So be careful of that. Because we're working out a remainder, it's always that minus that. So x cubed minus x cubed is nothing. 3x squared minus gives us plus x squared, 4x squared. Bring down the next term, minus 2x. So now, what do we do? Ask yourself the question, what do we do to the x to get, to get this term, the 4x squared. So what have we got to times x by to get 4x squared? 4x. Positive 4x, so that's plus 4x. So what do we do now? Right, to work out what that actually gives us, 4x times x minus 1, which is? Right, so that's our remainder. And notice that each time they're the same, so that they're going to disappear. What's my remainder going to be? 0 plus 2x. Yep, minus 2x plus 4x is 2x. So plus 2x, effectively. Bring down the next term, minus 2. So what's the last thing we're going to do, Andrew? This is where we ask ourselves, what have I got to times that by to get that? No. X times 2 gives 2x. Yeah. So we're going to multiply it by 2. So what goes up there? 2. Yeah. So what is 2 times x minus 1? Answer? Minus 2. 2 times 1 is 2. Yeah, so actually, I made that mistake the other day. Very easy to do. So that's what goes underneath here. 2x minus 2. What's the remainder? Minus 2 minus 2 is plus 2, 0. So in fact, it goes exactly. Okay? So we've got an exact answer. X cubed plus 3x squared minus 2x minus 2 gives x squared. Sorry, divided by x minus 1 gives x squared plus 4x plus 2. Right, to do the integral. If I'm asked to do, if I have two functions that I'm dividing, like this, yeah, what sort of scenario would this occur in? Well, these sort of linear and quadratic and cubic functions don't occur so often. You sometimes get we often get quadratic functions. We might be looking for the effect of one quadratic function with respect to another, so divided by another, and then you'd have to do the integral of that function. Or you might be tempted to do the integral of that function to find the area under the curve. Have you done anything like that in the other units yet, where you're trying to find the area to give you the work done, or no? Yeah, well, you will do. So if I wanted to do the integral of x cubed plus 3x squared, minus 2x minus 2 over x minus 1 with respect to x, I would then actually do the integral of my answer. So I do the polynomial division, and in fact that turns out to be x squared plus 4x plus 2. And that's dead easy to do. I can write down the answer to that, because when I do an integral I add 1 to the power and divide by the new power. So that's x cubed over 3. Remember, Andrew? And we integrate, add 1 to the power and divide by the new power. The next one will be over, right? And the next one will be, what happens to the 2 on its own? That's if you differentiate. Yeah, the x reappears, and then at the end goes plus, right? So that would be the answer. So if you have to do this integral, you do the polynomial division, and then it's straightforward. So actually, the answer to this integral is 3 steps. Of course, in between, you've got to do this polynomial division to get to this bit. And then so that's when we do it, when we've got to integrate a complex function that's got 2 terms in it, some sort of fraction like this. Well, the processes are the same. Of course, they get a bit longer, and there's little traps that you can fall into. I'm going to pause this here and let you have a look at this one on your own.